Look up tonight, pick any star. Now try to imagine that one of them is so large that if it swapped places with our sun, you would already be inside it. That is not a thought experiment. It is a measured fact about a real star called UY Scuti, sitting 9,500 light-years away in the constellation Scutum. Its radius is 1/700 times that of our sun. Place it at the center of our solar system and its surface swallows Mercury, Venus, Earth, Mars, and Jupiter completely. Saturn's orbit sits just beyond its edge. To feel that number honestly, our sun is already so large that 1 million Earths fit inside it. UY Scuti makes our sun look like a marble dropped into a sports stadium. But here is where it gets strange. A star this enormous should not exist. The physics of how stars work sets a ceiling, a point where the outward pressure of its own blazing light becomes so powerful it should blow the outer layers clean off before they can stay attached. Scientists call this the Eddington limit. UY Scuti sits right at that edge, and possibly beyond it. It is not exploding, it is not tearing apart. It is just there churning, crimson and violently calm. Astronomers have watched its surface heave with plasma columns each larger than Earth itself. The star is losing mass constantly, shedding material into the space around it like a slow, continuous storm, and yet it holds. So the real question is not how big it is. We know that. The question is what is actually keeping something this enormous from destroying itself. That answer turns out to be stranger than the size ever was. To understand how a star becomes that large, you have to start somewhere ordinary. Our sun is a furnace. At its core, hydrogen atoms are crushed together under enormous pressure until they fuse, releasing energy that pushes outward in every direction. That outward push, called radiation pressure, is the only thing stopping the sun from collapsing under its own weight. It is a balance. Gravity pulls in, radiation shoves out. For billions of years, those two forces hold each other in a kind of permanent standstill. But in stars born much heavier than the sun, 10, 20, 50 times more massive, that standstill is violent and short. The more massive a star is, the faster it burns. A star 30 times the sun's mass can exhaust its core hydrogen in just a few million years. The sun, by comparison, has enough fuel for 10 billion. Massive stars are not more powerful because they live longer. They are more powerful precisely because they burn out faster. Here is where it gets strange. When the hydrogen at the core runs low, the core contracts, it gets hotter. That extra heat floods outward into the surrounding layers, and those layers respond by expanding. Enormously, the outer shell of the star swells outward, cooling as it spreads, deepening from yellow to orange to red. The star has not gained mass. It has simply redistributed itself across a vastly larger volume. This is how a red hypergiant is born. By the time a star reaches UY Scuti scale, the numbers become almost impossible to hold in your mind. Astronomer Arroyo Torres and colleagues, measuring UY Scuti in 2013, calculated its luminosity at 340,000 times that of our sun. 340,000 suns, pouring out of one object, which raises the question the researchers could not easily answer. If radiation pressure that powerful is constantly pushing outward, what is actually keeping the star from flying apart entirely? Sources: Arroyo Torres et al., 2013. Astronomy and Astrophysics, NASA Solar Physics Division. Here is the thing that should keep you up at night. UY Scuti is not quietly burning. It is pulsating, swelling and contracting like a slow, colossal heartbeat, and with every pulse, it bleeds. In a 2013 study published by Arroyo Torres and colleagues, researchers calculated that stars like UY Scuti lose mass at a catastrophic rate through stellar winds. We are talking about shedding the equivalent of our entire sun's mass every few thousand years. continuously right now. Think of an ordinary candle. It does not burn from the wick outward. The wax melts from the outside, draining away layer by layer, the flame consuming what surrounds it. UY Scuti works the same way. Its outer layers are not waiting to explode. They are already leaving. In 1994, Roberta Humphreys and Chris Davidson, publishing in the Publications of the Astronomical Society of the Pacific, outlined what physicists call the Eddington luminosity limit. Every star has a ceiling, a maximum brightness beyond which its own outward radiation becomes so powerful it overwhelms gravity's inward pull. Past that point, a star simply blows itself apart. UY Scuti is operating dangerously close to that ceiling. The radiation pushing outward and the gravity pulling inward are nearly matched. It is a tug-of-war measured in astronomical distances, and neither side is winning cleanly. The star exists in a state of violent, slow-motion tension. Scientists still cannot fully explain how it holds together at all. So the real question is not whether UY Scuti will destroy itself. It already is. The question is, when the outer layers are finally gone, what does the core left behind actually do? Here is the part nobody tells you about the largest star in the known universe. It will not go out with a bang. When UY Scuti finally exhausts the last of its core fuel, and it will because every star does, the leading theory is that it will not explode at all. Stars massive enough may simply collapse inward, their gravity overwhelming everything in silence, producing what astronomers call a failed supernova. No blinding flash, no shockwave tearing through neighboring space. Just a star and then nothing where the star was. In 2017, a team led by Scott Adams published findings in the monthly notices of the Royal Astronomical Society documenting exactly this. They had been watching a massive star called N6946bH1 in a galaxy 22 million light-years away. In 2009, it brightened briefly. Then it vanished. No explosion was ever detected. The most likely explanation, it collapsed directly into a black hole, skipping the fireworks entirely. The largest star in the known universe may end the same way. Gone. But here is where it gets stranger. Astronomers cannot yet confirm UY Scuti is actually the largest. The team that measured it, Arayo Torres and colleagues in 2013, reported an uncertainty of plus or minus 192 solar radii. That margin is larger than most stars ever get. Another star could already hold the record, undetected somewhere in the dark. One final detail is hard to shake. The light reaching your eyes from UY Scuti tonight left that star 500 years ago. You are not seeing it as it is. You are seeing it as it was when humans were building the first cities. It may already be gone. What that means for everything we think we know about the universe is where this story ends. Here is what the night sky actually is. Not a window, a museum. Every point of light you see overhead is a message that left its source years, centuries, sometimes thousands of years ago. You are not seeing the universe as it is. You are seeing it as it was. That red point in the direction of Scutum, the one carrying the light of UY Scuti, left its source 500 years ago. Before the pyramids, before writing. That light has been crossing the dark ever since, and it is only now reaching your eye. Which means we have no idea if UY Scuti still exists. The star you have been watching this entire video may already be gone. Not dying, gone. The explosion could have happened centuries ago, and the news simply has not arrived yet. We are, in the most literal sense, looking at a ghost. This is not a poetic idea. It is physics. Light travels fast. Nothing travels faster, and even at that speed, 500 light-years is a journey that swallows millennia whole. Every star above you is doing the same thing, sending a delayed signal. Some of those signals are a few years old. Some are millions. The sky is not one moment in time. It is thousands of moments, all arriving at once. One person standing in a dark field, looking up, is receiving the entire history of the galaxy simultaneously. That is not a small thing to be. That is an extraordinary position to occupy. You are the receiver at the end of a 9,500-year transmission, and the message is still coming.